We've talked before about refraction through parallel-sided interfaces, such as a block of glass in air. And if you have a ray of light that's incident on the first surface, we could draw in a normal perpendicular to that interface. You could see that the ray of light was headed in this direction, but instead is refracted bent toward the normal. And when it hits the second interface, instead of heading in this direction, the light is bent because it's going from high to low index, away from the normal, something like that. And we know that because these two interfaces are parallel to each other, that these internal angles, theta 1 prime and theta 2, are equal to each other. Also, because the glass is surrounded by air, and N1 is equal to N3, we could also say that theta 1 is equal to theta 2 prime. However, refraction through a prism is a different situation, because the refracting surfaces are not parallel to each other. Here, a ray of light might be incident on the prism, travel through the prism, and leave something like this. And on this prism, this would be your first refracting surface, where the incident ray enters. This is the second refracting surface, where the emergent ray leaves. This top point is called the apex, and this is the apical angle. The angle between the two refracting surfaces. The bottom, the side that is opposite the apex, is called the base. And now if you were to trace a ray of light through this prism, the light hits the first interface at an angle to the normal. Instead of continuing in this direction, when it enters the higher index, it'll bend towards the normal. And you draw in another normal for the second incident point. And instead of continuing in this direction, when it goes from a high to low index, the ray will bend away from the normal. And now, because our two interfaces are not parallel to each other, we can no longer assume that theta 1 prime and theta 2 are equal. However, you will find that theta 1 prime plus theta 2, the sum of the angles, is equal to gamma, which is the apical angle. So for our example, if we were to tell you that for this prism the apical angle is equal to 35 degrees, the incident angle is equal to 15 degrees, and the index of the prism is 1.49. You can use this information to find the emergent angle. Since we know theta 1 prime and we know the two indices of refraction involved, we can use that to determine, and we know theta 1, and we can use that to determine theta 1 prime. So you use Snell's law, N1 times the sine of theta 1 equals N2 times the sine of theta 1 prime. We know that the prism, well, we'll say it's in air, so we have the first index of refraction as 1. Your theta 1 is 15 degrees, N2, the second medium, is 1.49, and we want to solve for theta 1 prime. And if we do so here, we would find that it is equal to 10 degrees. Now we need to find theta 2, and if we know that theta 1 prime plus theta 2 equals the apical angle, we found theta 1 prime is 10 degrees. We're looking for theta 2, and that is equal to 35 degrees. And so theta 2 would equal 25 degrees. And then you can continue to use Snell's law again. N2 times the sine of theta 2 equals N3 times the sine of theta 2 prime. Our N2 is inside the prism, 1.49 times the sine of 25. The N3 is back to the air, so 1 times the sine of theta 2 prime we're trying to find. And here you could solve for theta 2 prime, and you would find that it is 39 degrees.